hello, 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 hello.
A very good morning to the distinguished dignitaries, esteemed scientists, respected colleagues, students present here and offline. It gives me immense pleasure and honor to invite you all to this CSIR-CFTRI 75th Platinum Jubilee Series. CSIR-CFTRI, since its inception from 1950, has been pioneering in food science, revolutionizing the food processing technologies, addressing the needs of nutrition and innovative technologies, assisting in the enforcement of food quality and safety of food products. From developing complementary to supplementary foods for the targeted population, innovative, sustainable food technologies, and for empowering industries, students, academicians, and farmers and self-help group for skill development courses. Our institute has played a pivotal role in ensuring food safety, security, post-harvest needs, and added value to the agricultural commodities. This Platinum Jubilee year is one such milestone. It is a testament to our 75 years of relentless innovation, collaboration, and service to the nation. This Platinum Jubilee lecture series is a tribute to that legacy to acknowledge the relentless dedication of CSIR-CFTRI scientists and team of present and past who have contributed to this excellent and reach new heights of CSIR-CFTRI's innovation, excellence, and transformative contributions in food science. Now, may I kindly request our esteemed chief guest, Dr. Alok Dhawan, Director, Center of Biomedical Research, Lucknow, and former Director of CSIR, Indian Institute of Toxicological Research, Lucknow, and our beloved Director, Dr. Sridevi Annapurna Singh, to grace the dais and join us in the celebration of knowledge and innovation. Now, may I kindly request our beloved Director, Dr. Sridevi Annapurna Singh, to give a flower bouquet to our chief guest to have a warm welcome. Now it's my honor to invite Dr. Umesh Hebar, Chief Scientist, Department of Food Engineering Department, to kindly give a flower bouquet to our beloved director to extend our warm welcome to the celebration. Thank you, sir. Now, may I invite Dr. Giridhar Parvatam, Chief Scientist, Head of Department of Food Safety Analytical Quality Control, to kindly introduce the chief guest for today's session.
Good morning to you all. Now it's my pleasure to introduce our distinguished speaker of the day. Professor Alok Dhawan is currently the director of the Center of Biomedical Research in Lucknow. Previously, he served as the director of CSIR Indian Institute of Toxicology Research in Lucknow during 2015 and 2020, and also the director additional charge of CSIR Central Drug Research Institute during 2017 and 2018. Professor Dhawan was the founding director, Institute of Life Sciences, and also the Dean Planning and Development at Ahmedabad University, Gujarat. He has played a stellar role in building institutions of excellence in higher education and national laboratories across the country and was instrumental in establishing an innovation ecosystem. Professor Dhawan obtained his PhD in biochemistry from the University of Lucknow in 1991 and was awarded Doctor of Science degree in Life Sciences by the University of Bradford, UK in 2017. Professor Dhawan was significantly advanced in the fields of genetic toxicology, in vitro toxicology, alternate to animal models in toxicology, in silico toxicology, and nanomaterial toxicology at the CSIR IITR Lucknow. Recognizing the growing importance of nanotechnology, he pioneered the discipline of nanotoxicology in India and authored a comprehensive guidance document to ensure the safe and responsible use of nanomaterials across the various industries. Under his leadership, a state-of-art nanotech material toxicology was established at CSIR-IATR that equipped with advanced technologies for research and analysis. Professor Dhawan's efforts have been instrumental in shaping national guidelines for the development and regulation of nanopharmaceuticals and nanoagricultural products, as well as other related areas. Professor Dhawan's contributions have not only enhanced scientific understanding, but have also laid groundwork for safer applications of nanomaterials in diverse fields, thereby promoting public health and environmental safety. As a mission director, Professor Dhawan led a CSIR mission mode program focused on developing food and consumer safety solutions, collaborating with multiple CSIR institutes to integrate technological advancements. Professor Dhawan played a pivotal role in crafting robust risk assessment framework for fragrance materials. Additionally, he was key in the establishment of bedrock Bionest and also DSIR Common Research and Technological Development Hub at CSIR IATR that aimed at fostering entrepreneurship with the biotech sector. His efforts also included the establishment of national reference and referral centers under Food Safety Standards Authority of India that enhancing the regulatory framework and safety protocols. He has been conferred with the several honors and awards and fellowships. He is a Fellow of National Academy of Sciences, India, Fellow of Academy of Toxicological Sciences, Fellow of Royal Society of Chemistry, UK, National Academy of Medical Sciences, Fellow of Gujarat Science Academy, Fellow of the Academy of Environmental Biology and Academy of Science and Animal Welfare. He is also the Fellow of Society of Toxicology and founder of the Indian Nanoscience Society. He is an honorary fellow of Biotech Research Society of India and president of the Society of Toxicology and president of Uttar Pradesh Academy of Sciences. He was our Research Council member during 2020. He has, to his credit, more than 150 publications, 20 reviews on book chapters, 7 patents, 1 technology and 6 copyrights, and edited 11 books. Huge number of citations he had, that is 15,700 with H index of 60. It's my pleasure to invite Professor Dhawan to deliver this distinguished talk of Platinum Jubilee series. I request you all to give a big round of welcome applause to the speaker. Thank you.
Thank you, Girdhar sir. It is great pleasure to invite you, our distinguished CSIR scientist, former director of CSIR IATR and the current director of Central Biomedical Research, Lucknow, to present his insightful lecture on supporting risk in science, the bedrock of Atmanirbhar and Viksit Bharat. And thank you, ma'am, to occupying the seat back. The floor is yours, sir.
So at the outset, let me say Shubhodaya, good morning. Bharat Mata ki Jai. Why I'm saying Bharat Mata ki Jai? Because I was asked to plant a tree in the name of my mother. And when they asked me to sign the certificate, I've written Bharat as the name of the mother. So I think that's where we start. And also let me say what a privilege it is for me as a part of the CSR family to be here once again. It's like a homecoming for me. And that's why I said to Dr. Sridevi, please don't call me as a chief guest. You can't be a guest in your own home, right? So I've sat in this hall during your RC meeting, so I feel very sort of connected to the institute. And thanks very much indeed, Dr. Sridevi, for giving me this opportunity to share some of my thoughts at this very, I would say, joyous occasion of the Platinum Jubilee. So before I begin, I think I must compliment and congratulate all of you, the scientists, the technical staff, the students, the administrative staff, on the occasion of the Platinum Jubilee of CSIR-CFTRI. I think if you go down history, so within about 8 years of CSIR getting established, CFTRI was established. Right? So I think on a lighter note, CSIR was very productive. Within 8 years, they gave birth to CFTRI. Right? But that's how it was, because they wanted food, so they thought that's the best thing to do. Right? But I've learned much more of history today while walking through the various stalls that have been put up. So I've been more educated. And I think CSIR as a whole has been the harbinger for science, knowledge, and innovation in this country in all fields, all spheres of life. And it is very appropriate that when we talk of Platinum Jubilee of such a prestigious institute, that's not only provided us the food as it was required, as and when it was required, but also talking of foods of the future, that we also look at how sort of the innovation paradigm has catapulted CSIR and the country to where it is now. I think as we are fighting our enemies, we also see a lot of the technology that was developed by CSIR in collaboration with other organizations being put to use. So I think it's a very proud moment for all the scientists of CSIR that we are coming at a point where our technologies are being used to defend the nation as well. I think before I begin my talk, which is to do with basically supporting risk in science, and why I say so, and especially I just discussed with Dr. Sridevi when I was planning my talk. So the place where we are sitting, right? We talk of fancy words like corporate social responsibility, and we talk of people who are philanthropists and so on and so forth. But the place we are sitting was actually donated, right? So they knew the importance of science, and so they donated a palace for doing science. And same is true across the country. Most of the CSIR labs which were developed early on are in two palatial buildings, which were donated by the then Maharajas or people who owned those Havelis. So I think people understood the importance of science. India as a country has been at the forefront of science since inception, and since we know, for thousands of years. It was only when we got invaded that some of that got lost. Our ancient wisdom got lost, and I'm very glad that I was seeing some of the books that compendiums that the director was showing me, where you've gone ahead and actually put all the information regarding millets across the country in one compendium. So I think we're trying to get back our knowledge, ancient knowledge and wisdom as to how they're cultivated and what are the importance of those, or the nutrition values of these millets. So I think as we move forward, but all this is, as I said, is supported. So I think as our Honorable Prime Minister is always saying that we are looking forward to 2047 when India turns 100, and we should be a developed country by then. But I think it will be happening sooner than 2047, the speed at which we are going. And I'm very glad that I also speak to the future of the country, which is sitting right in front. I would have preferred they would have taken the front benches. That would have been even better. I think that is the kind of confidence we have in the youngsters who are taking science as a career. This is what is going to take the country forward. This is the risk that we are supporting. This is the future generation. Now you're what? You will be Gen Z, right? Not the alpha or beta, whatever it is now. But yeah, that's how the support is coming through generations. And we are the people, at least myself, I can vouch for it. Being the second generation CSIRian, my dad was the director of CDRI, and later, and that was in 89 to 92, I think. And then later on, I became director of CSIR-IITR. So he was a pharmacologist, I was a toxicologist. But nonetheless, I think in the history of CSR, this is the only example where a son and a father both became directors of CSR in this independent selection. So there's no way you can sort of hand over like it happens in the political parties. So today I'll be discussing, I would say, sharing a story with you of my own, how I was supported within the CSR system, because I talked to a lot of people and they say, well, it's very difficult to start something new. I said, if it is worth it, I think people are around to support. So it's just to showcase how things were supported within the CSR family and what it actually ended up doing. This is my current institute called the Center of Biomedical Research. It's an institution of the government of Uttar Pradesh under the Department of Medical Education. And we primarily are working on technologies and working on various aspects of various disease conditions so that we can improve the quality of patient care in the country. So I thought I should put that up front. And of course, the work that I'll be showing you is all related to CSIR-IITR. Okay. So this is how we perceive. I think that's where things start. So this is how we know our institute, or the parent body, as they say, Council of Scientific Industrial Research. And for you, I think this is what I feel. It's a citadel of scientists for innovative research. I think that's how, and this I had written for almost 10 years, 8 years ago, and now it says the innovation engine of India. I think this is the new logo that CSIR has come up with. So essentially, it is providing you that, the logo itself tells you that it is providing you enough room and opportunity to innovate, to create, to think. I never say outside the box. Just think, I think that's good enough. So I don't define the perimeter. Right? So again, when you talk of innovation, our building of the Toxicology Institute is a state building like all other government buildings. So when I wanted to put that up, I always do feel it's a very mundane thing to put up this picture. So I called a photographer. I said, I need a good picture of the institute. So on a weekend, he said, you please park the bus outside the institute. And then he brought some fancy lenses and he clicked this photograph. And I thought, this is brilliant, you know. So why I'm showing this photograph here is the perspective. You have to think differently. If you think like everybody else, then there'll be no innovation. Right? So I think you have to think differently and stand by it. That's the other thing. I think it's very important that you have conviction in what you've thought through. You should be passionate, of course, to follow through. So I think, so we had given a tagline, transforming lives through research and innovation, because all the materials that come to the market for consumption have to go through the portals of toxicology. And that's how we thought it's a translational science to begin with, right? So just for the youngsters, I think this is where we started. And then as and when the country required the different fields, the departments of the ministries were created, and the youngest of the lot is the Department of Biotechnology, which celebrated, I think, 55 years just recently. So I think CSIR, as I mentioned, has been the harbinger for the science, knowledge, innovation. And again, for the youngsters, I would say that you are always told sky is the limit. That's the spelling is SK and Y. And I always say sky is the limit, SK and I, science, knowledge, and innovation is the limit, which has no limits. It is just a ladder of excellence. You keep following it and, you know, with relevance, of course, and that's how you proceed. And I, again, would say I'm very fortunate that I'm here right now. I was here earlier, but yeah, it has taken time, nonetheless. So, and some of these slides, I got from one of our former DGs, Dr. Shekhar Mande, because I thought it'd be a good idea to give perspective when you come here. So I think as we were denied, whenever we were denied technology, the CSIR institutes and the country as a whole stood up and developed their own technology. So I think we are in the exponential phase now, and we can see that as we move forward, of course, we are providing enough competition to the global scenario, and we are marching ahead. We are already the 5th largest economy. We are headed towards the third largest economy soon. So I think that is where we are providing global S&T leadership in various fields. The way in which ISRO, for example, has come up with satellites and launch vehicles at a fraction of the cost of what the Western world was doing. So frugal innovation is the key, I think, of the Indian mindset. Okay. So this goes back when we were working. So we had 4 verticals in IITR. One was basic and applied translational research in toxicology. The other safety assessment, which is NABL and GLP testing. The third is, of course, skill development, outreach. And the fourth we started was R&D partnerships, which is to do with industrial service as well as incubation center. And I thought a very befitting name was given to it, which was called CSIR. Right? So CSIR, as you know, that as long as the CSIR is tuned well, you listen to music, otherwise it screeches. I think as CSIR, we need to align ourselves with the industry. We need to see what they want and then align ourselves accordingly. So then there'll be a good relationship or a coordination between the two. And then that is how you grow forward. So it is very befitting that we have such things in our institution where the industry can come and join hands. And as I mentioned, there were these different areas at that time which were in place, and but the center core was translational research. So you also find nanomaterial toxicology here as well. So yeah, this is me. Believe it or not, but true. Yeah, and this is the day when a meeting took place. This is my house in Michigan State on the day the meeting took place. I just took a picture, and these are the 2 professors, Syed Hasham and Vladimir Tarabara. So they said, we want to have a meeting with you. I was there doing some other work, but they said, we want to have a meeting with you to discuss some of our projects. I said, fine. So what is this project? He said, we are making fullerenes. This is 2005. Right? He's saying, Vladimir said, I'm making fullerenes with aqueous medium, and we want to use it for water purification. So we want you to do toxicology of these fullerenes. Now, if you're working abroad and you know, you have to be careful in what you say, you're part of the institute. And of course, when you don't know what he's talking about, you have to be even more careful. So at that time, I had no clue what nanomaterial is, right? So I said, well, how do I put it to him? I said, well, that's a fantastic idea. Of course, toxicology is our forte. We can do it, no problem. But you understand that this is a government institute. So I have to take permissions from the institute, and then I'll get back to you because it's an Indo-US collaboration. So he said, fine, there's no hurry. Let me know till next week. It'll be good. So immediately went back and searched as to what these nanomaterials are, what is happening globally. And so then I wrote a long email to the then director. Yeah. So this is the email I wrote, that this is what is happening, and I think we should start doing nanomaterial toxicology in our institute. And look at what he writes. Dear Alok, please go ahead. Best wishes, CM Gupta. Next day morning, I get this email. I think that is where he supported risk. I had no clue what nanomaterials are. I had no clue what toxicology would look like. But if somebody is willing to go to the moon, you just have to fire the rocket, right? That's how it is. So as a leader, I thought he did a fantastic job. He just said, go ahead. And next Monday, I went and told them, yeah, we can do it. There's no issue. And the rest is history. So he's the gentleman who was then the director of CDRI with, he had the joint charge of IITR at that time. So I think this is how risk was supported for me at IITR while starting a new field altogether in the country, which was very new globally as well. And I thought it was brilliant. If I was willing to take the risk, I had the support of the head of the institute. So then, as a result of that, this publication came out, Colloidal Dispersion of C60 fullerenes in Water, published in Environmental Science Technology, currently over 400 citations. For me, it is fine because it was the starting of nanomaterial toxicology. For these 2 gentlemen, Vladimir and Syed Hasham, it is one of their best papers in their entire career in terms of the amount of citations that they got. Primarily because it was an interdisciplinary work that they've done. So they are basically chemical engineers. They were persons of synthesis, and I did the toxicology of it. And so we had this wonderful paper that got published, and they also felt, at that point in time. So 2006 February, I came back, and in 2006 itself, it got published. So if you look at nanomaterials per se, I think this is what we were looking at, less than 1 nanometer in diameter, is the carbon fullerene. And if you look at the macromolecules, which is about 2.5 nanometer in diameter, so you can actually physically damage the macromolecules. You don't need to have chemical reactions, right? Physically, it can be damaged. So that is where the concern was at that time globally, that how we should allow nanomaterials, to what extent, how it will impact the environment, how it will impact the cellular system, the organelles or the organism. And so people were publishing, 2006, there was a paper in Science by Andre Nell, who said that if you take down the diameter of nanomaterials to about 5 nanometers in size, almost 60% of the molecules are at the surface, which means that you can utilize this property for catalysis, which is really good. But in the same vein, you'll understand that if it is so reactive, then it might lead to toxicity as well. So I think then we looked at, we wrote a review in nanotoxicology in 2009, where we looked at the various issues, but one of this was size. So if you take a bulk molecule, which I always, in our context, if we say bundi ka laddu, prasad laddu, whatever you call it, this is one surface area as a whole. But if you take out each of these bundis out and spread them out, so this will become like exponentially high. The surface area suddenly becomes very high. So then when the surface area becomes exponentially high, the reactivity also goes very high. So for purposes, if it is required, it is good. But other than that, it becomes very reactive in the biological system. Right. The other concern globally was being raised that, right from the raw materials all the way up to the end of life, everything will end up in the landfills or in the environment. So what you're looking for now, after decades of use of plastics, are the nanoplastics and microplastics that have come into our food chain. Recently, there was a paper that they've now found in postmortem brains that you have nanoplastics as well. So I think from that standpoint, they had cautioned. So there was always a caution of these nanomaterials, how they'll be disposed, how you can, they're so small you can't even detect them in the environment, right? So then when we started, we looked at the various issues that were related to nanomaterials, how we are going to do toxicity, how we are going to assess them, what will be the challenges. So one, of course, was when you make or synthesize nanomaterials, what is the coating, whether the coating is causing damage. So there was an example of this fullerene itself, where they had used tetrahydrofuran to make these fullerenes. And the THF was coated on top of the fullerene, and that actually went inside all the way up to nucleus. Otherwise, it will get metabolized. But because it is coated, it went inside the nucleus and caused DNA damage. So that was an important aspect that we had to look for. And then, of course, because we are small, so you have to look for characterization, visualization, so on and so forth. Dose metric was also interesting. So when you say it is nanoparticle, so are you going to give number of particles as a dose? Or you're going to give milligram per ml as a dose, or you're going to give surface area as a dose. Again, you can decide. Right? So all these were issues way back. Some of them still exist. So and we still don't have positive, negative controls for nanomaterials, right? Polydispersity, are they all same size nanoparticles or different sizes? So if they are different sizes and shapes in the same suspension, they might have toxicity, and you don't know which one is causing toxicity. Of course, size and shape is there. Then how do you extrapolate the toxicity from in vitro to in vivo and so forth? So the interesting one was this, the development and validation of test methods, which meant that is it possible, because of the size of these nanomaterials, the optical magnetic properties change, the colors change. So is it possible that you can get a sort of a response even without the cells? Because now they have changed their wavelength, and so you're getting a response which is actually the end point of the toxicology test. So ultimately, we ended up having a European Union FP7 project, which I'll show you. 19 countries participated. It was a 13 million euro project to get these tests validated, whether they are good for nanomaterials or not. The other important thing was, of course, there's no universal nanoparticle, as it says. So for the chemicals, it is easy. You can do testing of chemicals, and once it's done, you can publish the dossier and you're sorted. But for nanomaterials, it becomes difficult. So as soon as you change the shape, the size, the coatings or whatever, you have to do the entire toxicity again. So for the industry also, it was becoming an issue. How do you manage? Every time if something changes, you have to do the entire toxicological profile. So these were all the challenges. So now I'll share with you some of the challenges and how we overcame those challenges and what was the essentially outcome of what we did. We know output, these are publications, but when you talk of outcome, it has to be something substantial that has been of use to the country or globally. So, and these are just examples. We were looking at zinc oxide, which is used in the sunscreens now very commonly, and we wanted to look at how these nanoparticles would behave in epidermal cell line. You go down. Good, I don't want it to be sitting here in summer. So we took these zinc oxide nanoparticles at concentrations that are there after you wash off your sunscreen, right? And we looked at, of course, we had to do several kinds of techniques to come up with the size. Then so these are some of the characterizations we did. And then we looked at the morphology, right? This is again a very interesting slide. So we're looking at cells, and the student used to come back and say, so there's no toxicity, the cells are absolutely happy. So after a few experiments, I said, okay, let me check. So what was happening that when she was increasing the concentrations, the cells were dying and they would float, and she would just throw off the cells, and the ones that were sticking, she would take, and everything is fine. So when we counted the number of cells over the concentration, we found that a lot of cells are actually dying. So we published this plate as such, because that time everything was very fluid in the global scenario. So we had to, everybody was trying to publish as much as possible the nuances in the experimentation profile, so that next time you do, you understand why something has happened. So we published this, and we found out that in very low concentrations for up to 48 hours, you could find cell death happening, right? Okay. But again, the challenge was, if this is happening, is it because of the nanomaterial? So how do we say that it's because of nanoparticles? So is it, can we look at the uptake? So how do you look at uptake of nanomaterials in cells? You only require electron microscopy, which we did not have at that time. So we collaborated with CCMB. So our students came and they did all the experiments here at CCMB. But the issue was that you have to believe in those photographs that they show you. That's how it is. A couple of photos that they click, all the rest you may be counting 100, 200 cells, and that's about it, right? And of course, the amount of time that it takes to do electron microscopy, and the cells are sliced, so you can't take them back if you wish, right? So you can't reuse those cells, or you can't reculture the cells. So of course, this proved without doubt, and these are all published, that you had these particles inside the nucleus in the cytoplasm. These are titanium dioxide nanoparticles, which are also used in pharmaceuticals and paints now, and some zinc oxide nanoparticles. So internalization was confirmed that they have actually gone inside the cells. And this was an interesting study, which was separate from the one that I was showing you earlier, where we looked at primary human epidermal keratinocytes. And it's all about observations. So whatever I'm showing you is just the interesting part of all the studies that were done, so you'll appreciate what goes in, and all done by students, nothing, no credit goes to me. I think the front bench needs to, not you, but otherwise, needs to understand the importance of observation, right? So this student actually came up and said, well, we can find that the nanoparticles when exposed, they are moving from one cell to the other through philopodia. So it was similar to the movement of melanin that happens, right? So that means that a part of skin gets exposed really badly, then it will move on to the other parts of skin over a period of time. So I think this was really interesting. We had a collaboration with UK at that point in time, and this study was done there. So it was really good. So, but as I mentioned, these were the constraints. I've just shown you some fancy photographs, and you have to believe me what I'm saying. That's how it is. There's no proper statistics that you can do in electron microscopy. You do all your work, but statistics for the photographs not possible. So we had a flow cytometer in our lab. So we thought, is it possible that flow cytometry, again, if you understand the principles of flow cytometry, of course, it is simple, cost effective. You can do something like 50, 60,000 cells per minute. And these cells can still be taken back for culture. So we thought it would be a good idea. So going back to the basic principles, and whatever I'm showing you, even this we published, that these are the principles. So if you look at the cell, the forward scatter in flow cytometry gives you the size of the cell, and the side scatter gives you the granularity of the cell, how dense it is from inside. So if the nanoparticles are sitting outside the cell, then both will increase. If they've gone inside, the forward scatter will remain same, side scatter will increase. And if they're fluorescent, for example, in quantum dots, you'll get fluorescence plus side scatter increase. So with these principles in mind, we did some experiments. And I am not sure if you can see it, but yeah. So this is with titanium dioxide. The forward scatter was about 75,000, side scatter is about 6,000. And as we move forward with the concentrations, the forward scatter is about 61,000 here. Side scatter has gone up to almost 60,000, so almost 10-fold increase. So this proved the point beyond doubt that actually you can use flow cytometry for uptake of nanomaterials, and this is clearly visible. So now we had a test which could actually tell us as to what we can do, but of course we went back and forth and tested it with electron microscopy to finalize whether this is validated or not. The next step, of course, once it goes inside the cell, we wanted to look at whether it damages the DNA or not. So we did some studies on genotoxicity. So of course, there is repairable DNA, and then as you move forward, if the DNA is not repaired, either it goes under necrosis or apoptosis. But if it crosses through, then you can measure these under chromosomal aberration or micronucleus. And again, if it is lethal to the cell will die. But if it is expressed, then you have a mutation that you can, again, thymidine kinase mutation assay can be done. And the cell survives, then you have tumors, right? So that is the process. So we started from this place, and we did, as I mentioned, there was no positive control. So we used 1 millimolar ethyl methane sulfonate as a positive control. And we looked at very, low concentrations of zinc oxide nanoparticles in epidermal cell. You'll find that even at very low concentration, you do have significant DNA damage that has been observed in the in vitro scenario. So these are different parameters of the DNA damage that were measured, and all of them showed the significant change. And these are pictorial representations of how the damage looks under the microscope. So this is the control, this is positive control, and different concentrations of zinc oxide treated. So this is the nucleus, and these dots are the DNA that has come out in the electrophoresis. Then we went ahead and looked at whether this is going through or is it just repairable. So then we looked at whether it has gone through in terms of micronucleus. So again, we found that you did have micronuclei formation. Even at low concentrations, it was very significant. But interestingly, when we looked at titanium dioxide, we found that the particles actually go and stick to the cells. It is very difficult to wash them off. So now when you are performing the test, and this is again a published plate, it actually gives you a nightmare because these particles are sticking on top of these micronuclei. So basically it becomes a false negative or false positive at times, because under the microscope it is very difficult to differentiate. So then we came up with this idea that can we use flow cytometry to monitor these micronuclei, and we actually developed an assay for that as well, right? So because this is two-dimensional, it's on the slide. Flow cytometry is three-dimensional. It goes through the tube and you can measure it. So for the zinc oxide, we then proposed a mechanism that, of course, all the data was there. We started with nanoparticles that crossed through the membrane. They produce the active oxygen species, lipid peroxidation happens, then these particles also go inside the nucleus, they cause DNA damage, which I've shown you. They go into the mitochondria, release pro-apoptotic factors, and ultimately there's DNA damage, membrane damage, and the cells die. So this was the concept we proposed for the paper of zinc oxide, and then we published this. Now that is where the outcomes are. We published it in Toxicology Letters in 2009. Currently, we have like more than 800 citations of this paper. This was published in January of 2009, and it got through into the Science for European Commission, Science for Environment Policy special issue. In this entire page has been dedicated to our paper in April of 2009, within 3 months. So they were also looking for good quality studies and data that they can use for development of policy, right? And most of the electron micrographs that you see with permission have been published by Elizabeth Plorood. She's an author of this book from Canada. So she's taken up all the information about zinc and titanium dioxide that we published. She's taken copyright permission and published in this book, which is good to know. So then, of course, as I mentioned earlier, that there was a concern that these particles actually go into the environment and they may cause damage. So how do we assess that as well? So we looked at various trophic levels, and so we're starting with bacteria all the way up to Drosophila. So just to give you a sense of how we worked, I'll just show you for the bacteria. So again, the challenge was how to look for internalization of these nanomaterials in E. coli, which is ubiquitous. So we used both these assays, flow cytometry as well as TEM. And when we looked at this internalization, we found that in flow cytometry, you could actually monitor the uptake of nanoparticles. So this is only showing you the side scatter now, right? And you will see that when there's protein coating, with S9 fraction, it goes up to almost 40,000, starting from 8,000. And otherwise also, it's almost 3 times, depending on the concentration. And titanium dioxide was even more when we look at the amount of side scatter that has come up, right? So that was sure that it's getting inside the bacteria. Then we looked at zinc oxide, the electron micrographs. And while this was being done, I think this was a wonderful chance observation that we found that there's division happening in the bacteria and the nanoparticles are still inside, which means that the next generation, the first generation is exposed and the next generation is also having particles inside. So then we looked at multi-generation studies in bacteria using flow cytometry for almost 3 generations. And we found that even when you start, after the first exposure, you can still find nanoparticles in the 3rd generation, right? Both for zinc and titanium dioxide. And of course, we confirmed all these with in parallel with electron microscopy, so that was a validated method. So these are some of the electron micrographs, and ultimately at higher concentrations, the membrane gets disrupted and the bacteria die. Right. We also looked at salmonella because we are doing Ames test and we wanted to see whether it also gets taken up in salmonella. So it was also true in salmonella. These are the electron micrographs. And of course, so those were early days. I think we also looked at how much data we can provide. So when we are saying these are protein coated, so we also looked at the TEM and SEM EDAX, right? So we actually went ahead and quantified the elemental analysis. So in the case of zinc oxide, bare nanoparticles will have zinc and oxygen, but when they're coated with protein, you can see the peaks of nitrogen, carbon, and oxygen. They've gone up tremendously. This was approved, so you can actually target one nanoparticle and it tells you the elemental concentration of this particle. Similarly here. So the more data that you provide, I think that is what is important for us to see how critically we plan our studies and how it can contribute in the long run. Right? So this was for titanium dioxide. And ultimately the paper came out in Cytometry Part A, which is a journal that publishes methods. And then it became the featured article, which for them is like the cover page article. It was a new methodology that we had developed for nanoparticles uptake. This is also an interesting story. There's a student who joined me. He was the topper of his master's and he said, I want to do mole bio, as they always say. Right? I said, well, we'll plan what you want to do, but there was another senior PhD student who was going to learn in silico toxicology and how we can plan work. So I said, it will be best you go with him. You also have a training and then come back, we'll plan something. He never went back to the lab, but he did some wonderful work. And this was one of the examples. So we took graphene oxide and graphene. So these red dots are hydration levels. And we took alpha helical protein. So if this is hydrated, the protein remains the same. And then we did basically molecular dynamic simulation for this. And over a period of time, if this is not hydrated, then you will find that this protein will lose its helicity, right? It's almost going now. Now, the interesting part in this paper was that, yeah, it's gone. So over a period of time, so this paper is a problem that is a biological problem. We have used computational methods, in silico methods, to solve that problem. And the journal is that of chemistry. So you can't be more interdisciplinary than that. Because we published in a chemistry journal Langmuir, because we thought a lot of people were synthesizing different kinds of graphene for drug delivery at that point in time. So we thought it would be a good idea to showcase them what they're getting into. Right? Can you switch the next slide? So over a period of time at the institute, we developed the entire repertoire that was required, right from synthesis, characterization, cytotoxicity, immunotoxicity. A lot of scientists were working in this field. And we had the entire sort of things that were required to assess. So ENMs are engineered nanomaterials. Okay. And then, of course, we had a CSR network program with 17 institutions, where IITR was the nodal and all these different institutes were participating. Now the issue was, how do we move forward? So there were only two ways, because this was a new field coming up globally. So either I go around the world figuring out what people are doing, or I call people to India and let everybody get the benefits. So the first thing we did was to organize an international conference 2008. And for the youngsters, at least, you should remember the timelines. I'd only come back in 2006. That is where I had started. So this international conference was done in 2008. 2008, this lady standing here, she is Sally Tinkle, who had written the National Nanoscience Initiative of the US. So I invited her as the chief guest for this conference. And of course, the who's who of people across the world who are working in the field were invited. So we could get a sense of where this field is going. And then, as I always say, it's very important. Generally, we consider meeting, eating, and greeting, and we forget about it afterwards. But I feel whenever there's a conference or a meeting, we should look at the recommendations made or what are the outcomes of this. So essentially, we organized a session in which the people who had come from abroad, they also made recommendations, or the declaration, as they called it. All these recommendations were noted down. This was then sent to CSIR, it was published in the CSIR newsletter. And that became the starting point of how nanotoxicology would develop in this country, right? So then, fortunately, we got two European Union projects that were funded. One was this through UKRI, two of them from UKRI and two of them from European Union. So this was an interesting one, nanotoxicology link between India and European countries. And here we have actually went ahead and trained 7 or 8 countries in Europe how to do nanomaterial toxicology. Again, an outcome, not an output. And this one, as I mentioned to you, they were looking at whether the methods in toxicology are good enough or not. So this was a flagship project of the 7th framework of European Commission, where we participated as well. And this was almost 13 million euros worth of project. So, yeah. So this was the project. We had 19 countries participating, and because India is a big country, they said at the last moment, can you also have one more institute? So we added a CCMB because they had the electron microscope. So it's a good idea. And why I'm saying all this is that you should not shy from collaborating. I think it's always good, rather than just keep to yourself and not let things happen. It's good to collaborate as much as possible. So it's over the weekend, I just called my collaborator in CCMB. I said, I'm going to put your name and some 100,000, 125,000 euros against it. And this is the amount that I was getting. I think 150,000 euros, something like that I was getting. And so then this project went through, and it was really good that we could collaborate with all the major groups in the world, including US and Canada. While that was going on, we also, being aware of nanomaterials and how it works, we also wrote the first guidelines of handling nanomaterials in the laboratory. And that was published as part of the conference proceedings. This was the second international conference, 2011. There were 15 countries that participated. Here is CM Gupta, I can never forget him. Dr. Katoch, who was the then DG ICMR. Of course, representatives from UK, she's from Turkey, and others who were there, the former director of IITR. And all the abstracts were published in this Journal of Bio-Nanoscience, in which our guidelines were also published. This was released in 2011. This is the guidance. And this became, again, the starting point for the guidelines and guidance of the Government of India. Right. So, as I mentioned to you, this was the publication that we had in January of 2009, which later on was cited in the European Commission. I was fortunate, as I said, DST then did international comparative performance of India's research between 2009 and 14. And in the areas, the top 10 publications in pharmacology, toxicology, and pharmaceutics, there are about 14,000 people working in these 3 areas. The top 10 publications, the one that I just showed you, was also listed. So it was published, and we had, in terms of citations, about 215 citations at that point in time. So it was listed as one of the papers among top 10 in these 3 fields altogether. Right? And this was the paper I mentioned to you, became the featured article, which is like a cover page article for cytometry part A. This is the workshop we organized for the European partners to train them in the various nuances of nanomaterial toxicology, and they went back and established it in their own laboratories. And so this kind of timeline, right? So we, as I mentioned, that email that you saw was around 2005 November. I came back in February. We started setting up facilities in April. Now you have to look at the speed at which it happened. 2006, we had submitted our first proposal to DST. It was evaluated at the Indian Institute of Science. Mostly people from material sciences were there, and I went and presented, and the chairman said, well, Alok, you only asked for 30 lakhs. If you had asked for 3 crores, we would have given you. And you know who the person was? Professor Sood. Right? So I had no clue at that time. So I said, now you can give it to us. No, we had taken transferences. He said, no, that is already documented now. But yeah, it's good. At least you started toxicology. We were all struggling how to look at biological aspects of nanomaterials. So that got sanctioned, and then we made a society, Indian Nano Society in 2007, the first international conference that I showed you. All the abstracts got published in Nano Toxicology Journal. Then the first project came through in which we could have PhD students exchange between India and UK. Then we got the Nano Linen, which was again 8 countries, funded by EU. Then CSIR Nanoshi came through between 2012 and 2017. EU FP7 came in, and then 2011 we did another conference where 15 countries participated that I showed you as well. And the guidance came out in 2011. We then established our own facility, which was inaugurated by the then Honorable Minister of Science Technology, Dr. Harshvardhan, in 2016. 2017, one of our scientists did the evaluation through Web of Science. So CSIR was globally positioned among top 5 in nanomaterial toxicology. We were number 4. Number 5 was Harvard at that point in time. In 2017, University of Bradford bestowed its honorary doctorate on me for the work done on nanomaterial toxicology. And this was the first honorary DSc that they had provided in their 50 years of history from outside of the UK. And for all the work that I'd done in India, nothing was done outside of CSIR. So all the work that I showed you was from CSIR, and from there it has gone all the way, and they recognized it. And then we published our first book. It was an edited book on the various aspects of computational and experimental nanomaterial toxicology in 2017. Then in 2018, as was mentioned, we established the National Nanotoxicology Facility at IITR. The guidelines of nanopharmaceuticals came out in 2019, and the guidelines for evaluation of agri-based inputs came out in 2020. And both of them, I was an author as well as the editor. So it was indeed a very gratifying thing for me to see that I started with a small email, and this is where it turned out to be. I think we should always remember that if you put your heart and soul in something, don't worry about the outcomes and outputs, I think, but do worry about the experimental plan and what you want to do and what is the world doing around you at that point in time. So it's very important. So these are the 2 guidelines that have come out. They both are on the DBT website, free of cost. You can download them as PDF. Then in 2019, the Scientific Committee on Consumer Safety, this is from the European Commission, they came out with the guidance on safety assessment, and they cited some of our papers here. The Nano Mission came up with the guidelines that they cited our guidelines that we had published in 2011 as the bottom line on which this was based. And then in succession, we published 3 books on various aspects of nanomaterials. So basically what I'm saying is there's a volume of work that went through within no time. We didn't have time to bother or listen to what others are saying. We just put our head down and worked as hard as we could. I was fortunate that I had students who would believe in me, because at that time, in India, there was only one person doing nanomaterial, and that was us, only group. So at times I used to feel a bit anxious that I don't know whether we are going in the right direction or not, but now all of them are settled well. This guy did the in silico work. All these people are settled now, so either in India or abroad. The Lucknow TEDx chapter started, and they, I think 2017 or 18, and they were aware of what I was doing through the news articles, etc. So they invited me to inaugurate that by the talk, which kind of part of which I'm sharing with you now was how my science that I wanted to start was supported and what it has done for the country. So I think it's on both sides. I think it's on part of the audience which is sitting here to take that risk. Even though I was on my peak of my career, I took that risk and went to altogether new field of which I knew nothing. And of course the leadership to have supported that endeavor, and that's where we are now, right? And I think we were discussing yesterday, although it is in Hindi, I couldn't find an English version of this tweet. In 2020, CSIR has now signed an agreement with the government of UP as a knowledge partner. And this was the tweet that came out by the Honorable Chief Minister at that time. So now any project that has to be done in Uttar Pradesh, they already have an overarching MOU of the entire CSIR as a whole, in which I was instrumental in getting this done. Right? So I think, again, these are all support systems that we're putting in place. So when you look at the title, you will understand what I mean. End of the day, it is only science, knowledge, innovation that will take our country or the society up. It will, alleviate poverty. It will give you good health, so on and so forth. So everything, the quality of life will improve. So just for the kids, I think it's very important now. This I took from at some point in time from the Delhi IIT alumnus website, if I remember correctly. So we started here. We got to Stone Age, got to Iron Age, we got to Modern Age. We've gone back where we started. So I think and now AI is even worse. So up to Google was fine, but AI is even worse. So I think we need to depend more on the human intelligence, HI, rather than AI. It's very important for us to not forget that we also have a brain and mind that we can think differently. AI will perhaps give everyone the same answer, but humans will give you different answers. That's where the innovation index will be very high. So I think you should not forget that. For us, I think the EMI is all 100%. Earnest observation, which you saw through the slides, was motivation and innovation, all of them. So experimental protocols, which are not discussed, a lot of them were very innovative in nature. So the other thing you should be careful is that while you are doing all this creativity and innovation and science, you should not forget your environment. So this again is from the internet. This is a human face made out of animal species. I think as these animal species go extinct, human will vanish from the face of the earth. So it is important for us to ensure that we preserve the biodiversity, and I'm very glad that the director has now started a program where she's trying to revive the pond or lake, whatever it is, so that some biodiversity can come back. We also planted a tree this morning, so it's really good. So I think it's good for us to be aware of our environment and how we can preserve that as well. There's a picture again taken in Michigan, I think a day before Christmas or just after Christmas. Very interesting photograph actually, in terms of its scientific value. So this bird, so the geese are flying, this bird takes the lead and it creates a small vacuum behind it. So the other birds have to put less pressure. And that's how from a V shape to L shape they go on for thousands of kilometers. And when this bird actually becomes tired, it goes back and the next one takes over. So one lesson is that you should have a focus and believe in the leader. One. Second, when the leader gets tired, he should go back and let others move on. Not a tired leader should not sit on the chair for too long, otherwise things will go haywire. Nothing to do with you. Generally, I'm saying. So I think over a period of time, these birds have learned how to follow a focused path and achieve their goals. Is there a risk for them? 100%. They fly from one end to the other. They don't know what's happening in between. If there's a Ukraine war happening or Israel, they are not aware of it, right? But they trust their system, they trust their instincts, they take that risk and they move ahead. They trust on each other. So I think that's the entire ecosystem of science, right? You have to trust on each other. You have to foster collaborations. You have to believe in each other. If there's a critique that is coming through, try to see whether that is important for you or not. Take that into your consideration as well when you're planning. So I think it's always good that once you have you've got enough support that you should move forward and achieve your goal. Don't get bothered about what people are going to say and what they believe in. Don't worry. Just keep your focus and just hit hard. And the other thing I always feel is that are you going to leave a dry footprint or a wet footprint? Depends on you. So whatever knowledge you gained, if you just keep it to yourself, don't share it with anyone, then you will live. Once you're gone, you're gone. But if you share it with others, I think people might get excited. They might take it forward. So at least that legacy continues. I think CSIR-CFTRI has done a tremendous job in disseminating whatever knowledge it had to its stakeholders through entrepreneurs or self-help groups. So it has gone all over the country. I think it's remarkable that the amount of work CFTRI has done in terms of food on the platter that we have every day is commendable. So I think you've already left a wet footprint on the planet, on this country. But for individuals like us, it is important that each of us contribute, leave a wet footprint, tell people what you're doing, because end of the day, it's all public funded research that we do. For the kids, I think it's good to know that there should be an eye for observation. So if this is an experiment, you would perhaps look at a photograph and say, well, that's very good. But if you, for the same experiment, if you observe more carefully, you can actually see the person who clicked the picture. Same photograph. Depth of observation is different. Interpretation will become different. Right? Same photograph. So I think it's important that you have an eye for observation, but also try to be critical in observing as in-depth as possible. This was in Calcutta, 6:30 in the morning. Those days we had very small cameras with 2-inch screen at the back, digital camera. So I couldn't figure out what this bird was. So I just took inside and took it on the computer, laptop. Still couldn't figure out what this bird was. Right? Then I observed that actually it's the crow. This is the beak. This is the feather, and there is a ray of light coming through. Again, the depth of observation. I could have left it at this one, and I said, forget it. Whatever the bird is, doesn't matter. So curiosity should be there. Right? You should keep asking pertinent questions. Only then you will learn, you will evolve over a period of time. And this has not happened in the last 45 minutes. It has taken my entire lifetime. I've lived my life like this. So be curious, be hungry what you want, and keep questioning. And I think it's very important that you see successive prime ministers have supported science. And that brings me almost to the end of my talk. That they have always realized the importance of science. And they have figured out that, until there is science, knowledge, and innovation in the society, in the community, in the institutions, the country cannot move forward. So I think a brilliant example that we see now that if you start from Jai Jawan, forces are there, they've got the best military equipment, either from India or from abroad. They're protecting us. We are sitting pretty here. We don't have to worry. You look at Jai Kisan, all the scientific, even 2 varieties of rice got released, I think last week. New varieties have been released. So the institutions have done wonderfully well. We have more than we can even consume. So we exporters now. Of course, for research, Jai Vigyan was given by, I think, Dr. Mr. Atal Bihari Vajpayee ji. And then Jai Anusandhan was given by the Honorable Prime Minister, Shri Narendra Modi ji. So I think the essential bedrock is that you keep innovating, keep collaborating, keep creating, keep your ideas flowing through. And that is what is going to take the country forward as a developed nation, as a nation that we can all be proud of. Right? So I think what should I say? I would say onus is on all of us, but I think you students will be driving all this in the next 20, 25 years. So I think, yeah. And now there's a film, if you permit, of my present institution. That makes sense? 5 minutes? It's a 5-minute film. I'll just play it for you so that at least you know this was the talk that I wanted to give to you to make you understand what it takes for a driven system within the same family that we are sitting here to actually go from the bench all the way up to policy. And not only in this country, but other countries, and also train others. I was very glad to see your past records of CFTRI where, I don't know how many, 50 countries, students used to come to do their master's program here in food technology. So it is, again, I mean, all that was supported by the government, right? So what I'm saying is right from the beginning till now, our research, as long as it's a novel idea, it always gets support. I've yet to see an idea which did not get support, right? And now the community has come forward, the industry has come forward. They are also sharing the burden of sponsoring research. So I'll just, again, this is the tagline for this institute where I work, Advancing Frontiers of Science for Human Health and Wellness. And I hope it plays. I don't know, to be honest. You can raise the voice. Yeah, so thank you once again for your time and your patience and for giving me this opportunity to share my thoughts on this very joyous occasion of CFTRI. Thank you very much indeed. Thank you.
Thank you, Dr. Dhawan sir. The floor is open for the discussion. Are there any questions online? Yeah.
That's a very, yes, sir. Very interesting talk, sir. I have a couple of questions. Uh,
Huh? Can just say
We are
thank you to-
stopping the streaming online.
Yeah, can just say thank